Hello, this is an Algebra 1 video. It is Chapter 4, Section 3, and today we will be learning how to write equations in point-slope form. In 4.2, we learned how to write equations in slope-intercept form. In my opinion, sometimes these lessons are presented backwards, but I do want to kind of backtrack a little bit now that we have come to the point where we can explain point slope. I want to go back to 3.3. You'll notice on the board it says slope. We learned about rate of change and slope in section 3.3, and in that section we learned that provided you were given two ordered pairs, x1, y1 and x2, y2, you could calculate the slope or rate of change of the line by this formula, m equals y2 minus y1 over x2 minus x1. This is basically rise over run. And so what I wanted to show you today is how we can manipulate this one formula to get both the slope-intercept form and today's point-slope form and how that happens. So the first thing I want to do is if we were to take this slope formula and multiply both sides of the equation by x2 minus x1, what would happen is on the right hand side this factor would cancel with that factor and you would be left with just y2 minus y1 equals m times x2 minus x1, because on the left hand side it wouldn't cancel. So you would actually get this. Well, believe it or not, this is actually today's formula. In a nutshell, our point slope formula is not y2 minus y1, but y minus y1. So the only difference is that we're taking the little subscript 2 out of the equation, but y minus y1 equals m times x minus x1. So both the x2 and the y2 will get removed. And that's because at the end of the day you want to have your x and y variables still present. So, pardon me, I'm a little under the weather here, but anywho, so this is actually the point slope formula. This is why to me it makes more sense to teach slope formula, and then the next progression is naturally point slope formula. And then from the point slope formula, you can actually get the slope-intercept formula. Now, if you remember, the slope-intercept formula was from 4.2. That's y equals mx plus b. And the way we do that is very simple. You take this formula, and what this formula says to do is, in this case, that's why the name is called point slope. In order for you to use the point slope formula, you need two things. You have to have a point, and it could be any point, and you need to have the slope. So the slope gets plugged into the m, and your point gets plugged into x1 and y1, and everything else stays the same. But the slope-intercept formula is different because it also requires the slope, but it also requires the intercept. This doesn't say slope-intercept, this is point slope. So in this formula, you can use any point you want. But in the slope-intercept equation, you're really only supposed to be using the intercept. And we know that we have the intercept because we learned before that the y-intercept for a line is the point 0b. Well, what if we took 0b and called that my x1 and my y1? And then let's say that we have a slope is given to us. So we have the y-intercept and we have a slope. And we're going to call the y-intercept x1, y1. And we know that the y-intercept has to have an x-coordinate of 0. And that we always use the letter b to denote the y-intercept. So if we were to use this equation and plug in the information we have, we would get this. Y minus y1. Well, what is y1? B equals m times x minus x1. Well, what is x1? 0. And if we simplify this equation, then we get y minus b equals mx, because x minus 0 is just x. And then if we add b to both sides, this is how we get the equation from the previous lesson, y equals mx plus b, which we call the slope-intercept form. All right, so now, again, just want to remind you of the progression. We started off with the slope formula, which was y2 minus y1 over x2 minus x1. Now from that, we multiply both sides by the denominator, and we ended up with this point slope formula. And if we plug in 0b as our x1, y1, then we get the slope-intercept formula. So basically, all of these are very connected. So right now what I want to do is, now that we have both formulas, I want you to begin what they want us to do in the lesson. So it says here, write an equation in point slope form. It doesn't say slope-intercept, it says point slope form. For the line that passes through and they give us a point. So I'm going to go ahead and label. So this is going to be my x1, y1. And it even tells me what my slope is. Slope is 1/4. Then it wants me to graph the equation. Well, actually, writing the equation in point slope form is very simple. Again, the formula says y minus y1. And in this case, my y1 is -2. So this is y minus y1 equals m, which is 1/4, times x minus x1, and in this case, x1 is 3. Now, aside from wanting to simplify the minus negative here to make it a y plus 2, we don't have to distribute. We don't have to solve for y. This is the equation in point slope form. You just leave it like that. Now, we want to graph it. Now, because you don't have the y-intercept, you can't graph it the way we graphed y equals mx plus b, but it is very similar. The only difference is that we're not going to start at the y-intercept. We're going to start at the point that was given. So they gave us the point 3, -2. So we're going to come over here to our graph, and we're going to say, here's x1, 2, 3, that's positive 3, y is -2, so we're going to start right here at 3, -2. But aside from that, we're going to apply the slope in the same way we did in the previous lesson. And since my slope is 1/4, that means I'm going to go up 1 unit, and I'm going to go to the right 4 units. 1, 2, 3, 4. And if I wanted to, I could even go backwards. Instead of going up and to the right, I could go down 1 unit and then to the left 4. 1, 2, 3, 4. Either one of those would work. So now we're going to connect our points here. And just like that, we get our line. And there you go. That's how you graph, and that's how you write the equation. So now I want you to try this one on your own. And once you've done that, we're going to move on to writing equations in standard form and in slope-intercept form. So at this point, we have done standard form was the very first thing we did. And we did that a while back. And if you don't remember, I want to remind you that standard form is ax plus by equals c. And there were some stipulations. A, b, and c could not have any common factors. A should always be positive. And you don't want any fractions. A, b, and c should all be integers, not fractions. So that was standard form. And what I have here is an equation in point slope form. So they basically want me to transform it from point slope form to standard form. So the first thing we want to do is perhaps get rid of the fractions, because we know that we're not allowed to have fractions in standard form. So I'm going to go ahead and multiply in both sides of my equation by 3, because that is the bottom of the fraction. Now, if I didn't have a fraction, I could skip this step. But since I do, I'm going to go ahead and go 3 times y is 3y. 3 times -1 is -3. And then my 3 times -2/3, my 3 on the top and my 3 on the bottom are going to cancel. And I'm just going to get -2 times x minus 5. Now, some of you might be thinking that I need to multiply the fraction by 3 and the x minus 5 by 3, and that's not true. Let me remind you that this is negative 2/3 times x minus 5 times 3. Whenever you have three things being multiplied, we don't go 2 times 4 is 8 and 2 times 3 is 6 and then 8 times 6 is 48. That is not what we do. We say 2 times 4 is 8, that's done, and then 8 times 3 is actually 24. 24 is the right answer. In other words, you don't multiply both things by the 2. You only multiply the first by the 2, and then that result times 3. So I say that because a lot of times people don't realize that when you're looking at this, there are three things happening here. I have negative 2/3, and I'm multiplying it by x minus 5, but these parentheses keep that all together as one thing, and then I'm timesing it by 3. So the fact that I already took negative 2/3 times 3 and got the 3's to cancel, I no longer multiply the x minus 5 by 3. It canceled. So all that's left is the negative 2 and the x minus 5. So I hope that makes sense. If not, I can explain it again in class. So anywho, now we've gotten rid of all the fractions, but now we want to have all our integers on the same side. And our constant needs to be on the right-hand side. So I'm going to go 3y minus 3 equals, distribute the negative 2 times f, which is negative 2x, and then negative 2 times negative 5 is positive 10. Okay, at this point I need to bring my x's to the other side, so I'm going to add 2x. And then I want to take my 3 to the other side. And finally I get 2x plus 3y equals 13. And now this is standard form because 2, 3, and 13 don't have any common factors. All of the numbers, all the coefficients are integers, and my x value is positive. So that is how we do that. Now I want you to try this little one on your own. And then we're going to move on to a very similar question. Again, we are starting with point slope form. This is point slope form. But they want us to write it or transform it to slope-intercept form. This is actually a lot easier than the previous one. But again, I want to remind you, slope-intercept form, if you have forgotten, is y equals mx plus b. So in other words, I need to get rid of these parentheses, and I need to have the y by itself, basically. So to do that, we are going to distribute the 3/2 times x, 3/2 x, and then 3/2 times 1 is 3/2. Anything times 1 is itself. And then we want to subtract our 3 to the other side because we want y by itself. So y equals 3/2 x. And then we need to add 3/2 and negative 3. So I'm going to go ahead and go and find myself a common denominator. And I know that 6/2, 6 divided by 2, is the same thing as 3. So instead of saying 3/2 minus 3, I'm going to say 3/2 minus 6/2. And then 3 minus 6 is negative 3/2. So minus 3/2. And this is my equation in slope-intercept form. My slope would be 3/2 and my y-intercept would be negative 3/2. So now you can do it yourself number 3, and then we'll go on to our last example. All right, so in this example, we have a square that has been given to us. There's a figure there, it's square RSTU. And they want us to write an equation in point slope form for the line containing side TU. So this is TU. So probably the first thing we need to do is find out what the coordinates are of T and U. So it looks like for T we're going to get x is 7 and y is 1, 2, 3, 4, 5. And then for U, 1, 2, 3, 4, and the y value appears to be 2. So we have 2 points there. Now to write the equation in point slope form, remember we need to have a point. and we need to have a slope. We already have a point. We actually have 2 points. So this part of the process is done. We know that we have a point. What we don't have is a slope. In the previous example, example 1, they told us what the slope was. In this case, we don't know what the slope is. But because we have 2 points, we can use the slope formula to calculate our slope. So, I'm going to come over here and just label my points, x1, y1, and x2, y2. And then the slope formula says to do y2, which in this case is 5, minus y1, which in this case is 2, divided by x2, which is 7, minus x1, which is 4. So 5 minus 2 is 3, and 7 minus 4 is 3, so my slope happens to be 1. So now that I know the slope and I have a point, then I can go ahead and write this in point-slope form very easily. Y minus y1 is 2, my slope is 1, times x minus 4. Since we don't have to write the 1, you can actually reduce that to y minus 2 equals x minus 4. And this is the equation of the line in point-slope form. Now, it also wants us to go ahead and in part B, write an equation in standard form for the same line. So we already have this guy, so all I need to do now is transform this into standard form. And so remember what standard form, you want the x and the y on the same side. So in order to do that, I'm going to subtract the x over here, I'm going to add the 2 over here, and I'm going to get negative x plus y equals negative 2. Now you might think that you're done, but remember that they're all integers, there's no fraction, that's okay. But there's no factors between x, y, and negative 2 that are common. But the third thing is that you're supposed to start with a positive x, and this is not positive x. So what you can do is multiply everything by negative 1, and when you do that, you're going to get a positive x, a negative y, and a positive 2. So this is your final answer. X minus y equals 2. Alrighty? Okay. So now we are going to have you do this last. Now, by the way, this example is still referring to example 4. So when it says the line containing side ST, it's based on this diagram. So make sure that you have that. So once you've completed this example, you will have completed your notes for today, and I will see you in class, and thank you for watching.